So the formula, and again, this is just the formula that I'm going to copy on the back side, is the sine of angle A over A is equal to the sine of angle B over B, which is equal to the sine of angle C over C. So when you're setting up triangles, just to make sure that you're labeling your triangles correctly, when you see an uppercase letter, that is representing an angle. So I'll call this angle, angle A. The side opposite angle A, I'm going to label with a lowercase letter of A. So the lowercase letters represent sides, the uppercase angles represent angles. And again, it doesn't really matter when you're drawing your triangles where you place the A, B, and the C. So again, side C goes opposite angle C, side B goes opposite angle B. So now, when do we use law of sines? We use law of sines to solve an oblique triangle. An oblique triangle, if you remember back from geometry, is when you have an acute or an obtuse triangle. What's an acute triangle? Do you remember from geometry? All of the angles are what? Less than 90 degrees, exactly. An obtuse triangle has what? What's an obtuse triangle? One angle. Can it have more than one obtuse? No. So remember, of obtuse triangles, you have one angle that's greater than 90 degrees. Like I said, an oblique triangle is not a right triangle. It doesn't have that hypotenuse. So SOHCAHTOA won't work to help us solve for sides and solve for angles. So it's either you're looking at an obtuse or acute. So there's three conditions where you would use law of sines. There'll be other conditions that we'll talk about on Friday where we'll have to use the law of cosines. If you have two angles at a non-included side, so if you remember back from geometry, you guys studied all those similar triangles, the ASA, AAS, etc. Again, if I give you, I'm always going to give you three pieces of information about the triangle, and it's up to you to find the other three pieces. So if I give you two angles and a non-included side, so if I give you two angles at a non-included side, that's your AAS scenario. That's when you're going to use your law of sines to help you solve for the remaining three pieces of information regarding the triangle. If I give you two angles at an included side, so that's the side between the two angles that I give you, that's your ASA. That's a second condition where you would be using your law of sines. The third condition, which we're not going to talk that much about, is if I give you two sides and a non-included angle. That's your SSA. Notice I'm not spelling it the other way. Now, back in geometry days, when you were proving similarity and you were proving congruence, your geometry teachers told you that you could not use SSA to prove similarity or congruence. We're not proving similarity. We're not proving congruence. We're just trying to solve for missing sides and angles of the triangle. We're not going to get into this SSA because this is what we call the ambiguous case. Because three things could happen if I just give you the two sides and a non-included angle. You may have one triangle you can solve for with that information. You may have two triangles that you could solve for. So you'd have to solve for two completely different triangles, or the information given may produce no triangle at all. No triangle could exist. Again, that's all you really need to know about SSA. I'm not going to have you get into solving if I give you the two sides and the non-included angle. So really what we're going to concentrate on is if I give you the angle, angle, side, or angle, side, angle. So we're going to solve the following triangle given this information. Again, we're always rounding decimals, remember, to 3. Okay? So I'm telling you the angle B is 45, angle C is 95, and side C is 5. So the first thing you want to do is let's draw your picture. Let's draw my triangle. It doesn't matter where you put A, B, or C. So I'll call this angle A, angle B, angle C. So angle B, they're telling me, is 45 degrees. Angle C is 95 degrees. Side C, remember, is opposite angle C. So that leaves me side A, side B, and angle A to solve for. So any questions on how I've set this up? Now refresh my memory from geometry. What do all three angles in the triangle going to add up to equal? 180. Well, since I know 2 out of the 3 angles in this triangle, how can I solve for angle A? I can do what? Simply take 180 degrees and subtract from that the sum of 45 degrees plus 95 degrees, using your triangle sum theorem. So let's see, 45 plus 95, so that's going to give me 40 degrees. So like I said, if you know 2 of your 3 angles, if I give you 2 of the 3 angles, you can just add them together and subtract from 180. So any questions on how I solve for angle A? So now this leaves me side A and side B that I can solve for. So in order to use the law of sines, you've got to know an angle and a side opposite that particular angle. So in other words, when you're setting up your fractions for law of sines, you always have to use a side and an angle opposite that side. And you always want to use given information as much as possible. So what I'm going to do is I'm going to use the sine of C over C. So I'm going to take the sine of 95 degrees over side C, which is 5, equals. Now it's an eeny, meeny, miny, mo, which side you want to solve for first. If we want to solve for side A or solve for side B. I'm going to go ahead and solve for side B. So I'm going to set up the sine of 45 degrees over side B. So the way you use your law of sines, yes, there's 3 fractions equal to each other, but you take 2 out of those 3 fractions and set them equal. Any questions on how I set that up? Now, how do you solve for B? What do you think you're going to do to solve this? Cross multiply. So I have B times the sine of 95 degrees is equal to 5 times the sine of 45 degrees. Then what, to get B by itself, what am I going to do to both sides? Divide by sine of 95. And now you're just going to punch this in the calculator. By the way, what mode should your calculators be in, guys? Radians or degrees? Well, what's the unit of measure that the angles are given to you in? Degrees. So make sure you pay attention. These angles are all in degrees, so make sure in your calculators you change your mode into degree mode. So now I'm just going to type in 5 times the sine of 45. Make sure, guys, you close your parentheses after you type in 45, divided by the sine of 95. And I have a side B to be about 3.549. Okay? And again, round to 3 decimal places. So any questions on how you solve for the side using the law of sines? So now, going back to your triangle, so I know that B is 3.549. Again, I know that angle A is 40 degrees. So I still have one side left to solve, and that is side A. So again, I'm going to set up my law of sines again. You still want to use what was given originally. Don't use rounded answers to calculate another rounded answer. You're going to get further and further away from what the answers are going to be. So use what was given. Use the sine of 95 degrees over 5 is equal to sine of 40 degrees over A. Again, what am I going to do? I'm going to cross what? Cross multiply. So I have A times the sine of 95 degrees is equal to 5 times the sine of 40 degrees. And then divide by sine of 95. So 5 times the sine of 40 divided by the sine of 95. So I end up with 3.862. Yep. Did I do what? Oh, 409. Oh, yes. Hold on. Yeah, you're absolutely right. That'll be 5 times the sine of 40. Sine of 95. That'll make a difference. 3.226. Thank you. If you could type in the calculator. So 3.226. Okay? So then side A is about 3.226. Another theorem I want to make you aware of, back from geometry. You remember, guys, you did talk about a relationship between the largest angle in relationship to the side opposite. What happens with the largest angle? The largest angle will have what side across from it? It will have the what?
Smallest.
Biggest. Largest angle will have the opposite. So when you're labeling this, just in case, because careless mistakes can err, go back to your triangle. Your largest angle is 95 degrees. So that should have the longest side across from it, which is side 5. 40 degrees is your smallest angle. So it should be opposite the smallest side, which it is, 3.226. So double check when you're setting these up to make sure that you didn't carelessly make an error, aka type in the wrong angle in your calculator like I just did. So any questions on how the law of sines works? So let's take a look at another one. So again, they're giving me triangle ABC. So again, I'm just going to label this ABC. It doesn't matter where you put A, B, and C. They're telling me that angle B is 35 degrees, angle A is 25 degrees, and side C is 4. So here's side A, here's side B. What scenario is this? Is this an AAS or is this an ASA? Two angles and what? Is this side included or not included? Included. So this is an ASA. So any questions on how I labeled the triangle so far? So I'm giving you 2 of the 3 angles so I can go ahead and calculate angle C. So I can take 180 degrees and subtract from that the sum of 35 degrees plus 25 degrees. So 180 minus 35 minus 25. Give me 120 degrees. So like I said, it doesn't matter. It's an eeny, meeny, miny, mo which side you want to solve for first. If you want to solve for side A or you want to solve for side B. So I'm going to go ahead and solve for side B. So I'm going to take the sine of 120 degrees over 4. Remember, you always have to, when you're setting up your law of sides, you've got to know an angle and a side opposite for one of your fractions. So sine of 120 over 4 is equal to the sine of 35 degrees over B. So just like I did in the other example, what am I going to do to solve for B? I'm going to have to do what? I'm going to do what? Cross multiply. So B times the sine of 120 is equal to 4 times the sine of 35 degrees. And I'm going to divide by sine of 120. So 4 times the sine of 35 divided by the sine of 120 is 2.649. So B is about 2.649. So any questions on that one? You guys go ahead and solve for side A for me. we'll come up with about 1.952. Okay? Again, remember, double check. The largest side should be 4, which is opposite the largest angle, which is 120. The smallest side should be opposite your smallest angle, which it is 25 degrees, is opposite the 1.952. So any questions on how you can use the law of sines to solve for the missing angle? Again, I've got to give you the two angles and a side in order to set up the law of sines, either the AAS or ASA. Any questions on how we use that to solve for the angles and or the sides? And a lot of times, guys, these problems will involve some kind of word problem. Again, if a picture is not given, always draw your picture, draw your setup. So you have an airplane that takes off from carrier B in a straight line for 12 kilometers. At that instant, an observer on destroyer C, located 5 kilometers from the carrier, notes that the angle is determined by the carrier of the plane is 37 degrees. So they've already set up the picture for you. How far is the plane from the destroyer? So I'm trying to solve for side B. So before you can get this set up, you're going to have to know what angle B is going to be. You have to know angle B in order to solve for side B. The issue is they do not give you two angles. So what you're going to have to do, like I said, for law of sines, you've got to know a side and you've got to know an angle opposite that. So if I can find angle A, then I can simply add A and C together and then subtract it from 180. So since I know that angle C is 37 degrees and the side opposite that is 12, I can use my law of sines. So I can set up the sine of 37 degrees over 12 is equal to, again, I do not know what that angle A is, so I'm going to have to find the sine of A over 5. I can't directly solve for side B of this triangle because I do not know what angle B is. So just like in the last one, I'm going to have to cross multiply. So 5 times the sine of 37 degrees is equal to 12 times the sine of A. So I want to divide by 12. Now, using my calculator, how am I going to solve for an angle? Those of you that already watched the 6.1 video, we went over that. How am I going to solve for an angle using my calculator? I can't hit the sine. I'm going to have to hit the what? Second sine. You're going to have to use the inverse sine. So angle A is going to be equal to your inverse sine of 5 times the sine of 37 degrees all over 12. Anytime you're solving for an angle using your calculator, you're going to have to use your inverse functions, your inverse sine, inverse cosine. All right, so to solve for the angles, so if you have to use your calculator to solve for an angle, you have to use your inverse functions. So I'll hit my second sine, and I'm going to type in 5 times the sine of 37 divided by 12. So up of 14.522 degrees. So any questions on how I solve for angle A? So now how can you solve for angle B? What can you do? You can simply add these two angles together and do what? Subtract it from what? 180. So that gives me 128.478 degrees. So like I said, with these word problems, sometimes you have to find the other pieces of information in the triangle first before you can directly answer the question. Now that I know the angles opposite the side I want to find, now I can set up my law of sines to help me solve for side B. Again, use the angle and side that's given originally. So use the sine of 37 degrees over 12 is equal to the sine of 128.478 degrees over B. And we can cross multiply. B times the sine of 37 degrees is equal to 12 times the sine of 128.478. And then divide by the sine of 37. Bless you. 12 times the sine, 128.478, divided by the sine of 37. So side B is going to be about 15.610. And my units is going to be kilometers. Okay. So any questions, guys, on using the law of sines? Okay, we'll save the last example as our warm-up to do in class on Friday. All right, so any questions on law of sines? So like I said, the lessons for this whole unit are going to be about that long, so they're actually very short units. So that's why we'll be spending time in class getting ready for the midterm. So guys, just so you know, looking at your calendar again, without